Hello there and welcome back. So with this video we're going to start using a data binding library in our project. So what is a data binding library? Well, Android data binding library is a very powerful support library which makes it possible to bind data to views in declarative format using XML layouts instead of setting them programmatically. So data binding library helps you deal with find view by ID in a more elegant way to reduce boilerplate code, but when used in its full power, data binding library has many other benefits. So before you start using data binding, you need to enable data binding from Gradle scripts by adding the following piece of code inside the Android block of the module level build Gradle file. And if you are using Kotlin, you should also add a Kotlin kept plugin. And for the dependency, you should add the dependency for Android X. And enabling data binding doesn't automatically generate binding implementations for all your layouts. So in order to let your library know that you want to implement a data binding for a specific layout, then you need to make some small changes in the layout. In order to let your library knows that you want to implement data binding for a specific layout, then you need to make some small changes in the layout file. So suppose you have a layout like this, just a simple constraint layout as the root element and some views inside, and then you will need to wrap this root layout inside the layout tags, and it will look something like this. You don't need to manually add this tag layout. Android Studio can automatically convert your layout to data binding layout easily. You just need to click on your constraint layout element in this case and press Alt plus Enter, and you will see the option to convert data binding layout. This small change is enough for generating a binding class for this layout and binding the views inside. When you rebuild your project, Android Studio will generate a binding implementation class for this layout and name it by converting the name of the layout to Pascal case and adding a binding suffix. So for instance, if the layout file is named activity main XML, then the generated binding class will be named activity main binding. And if your layout is named fragment list XML, then your binding class will be named fragment list binding. So basically it will also add this binding suffix to your layout name. In order to have access to these views from your Kotlin code, you will need to get the instance of the generated binding class, and it is recommended to get this instance while inflating the layout. So in most cases you would want to convert your fragment layout file to data binding layout, and you would write a code which will look something like this. But if you want to use it in activity, then it should look something like this. If your compiler cannot find that binding class, then you should probably just rebuild your project and everything will work fine. Once you have an instance of your binding object, you will have the access to the views on that layout as properties of that binding object. Each view will be named accordingly to their view IDs, converted to a Pascal case. For instance, if you have a view with the ID of product underscore name, then you can call it on your binding object like this. Suppose we have created our custom model class and we want to bind it with our data binding layout. Now, in most cases in our data binding layout, we would have a data element tag and another variable element tag inside. And this variable element will have two attributes, a name and a type. So for the name we can specify, let's say, a person, and for the type, in most cases, we want to choose the path of our model class. Suppose we have a model class named person, and our person class has two fields, first and last name. Then as a type attribute on our variable element, we would type the full path of that class. For example, if the person class is located in a package named fragments, then we would write something like this: com.myapp.fragments.person. Then from our activity or fragment, we would want to bind this model class with our variable element from our layout file. And for that we would just use already defined instance of a binding object to get the reference of that variable name and bind it with our model class. And now from our data binding layout we can just use this variable to directly access this person class and its fields. So for example, we can use it to set the text to our text view, but we need to follow the proper syntax. So if you want to reference your variable fields, then you need to use @ sign with curly brackets, and inside you would specify your variable. And this way we have avoided writing boilerplate codes in our fragment class, and instead we have specified the text directly on our text view in this case. There are many more great things which we can use from our data binding library, for example, binding adapters. So what are those binding adapters? Well, binding adapters are essentially just regular functions annotated with a binding adapter annotation, which can be used as a custom view attributes in our layout file. A very typical use case for defining a custom binding adapter is for loading images with Glide or Picasso library, and we can define a custom attribute which takes the image URL and loads the image by using Glide or Picasso. And as you can see, binding adapter is just a simple function with the parameters, and the first parameter is the actual view on which we are going to use our custom binding adapter, and we don't need to specify it explicitly. And now we can apply that custom attribute on our image view directly. Of course, this means that we have already created a variable with the name of model, for example, and we have binded that variable with some of our custom model classes, which contains image URL field in this case. And with the custom binding adapters, we can remove a lot of boilerplate codes from our activities or fragments. And if you are still confused with the data binding library, don't worry, because it is normal to be confused if this is the first time you are hearing about data binding library. But I assure you that everything will make more sense in the next videos when we start using data binding library on real practical examples. Hello there and welcome back. So in this video I just want to shortly introduce you with binding adapters, which are used together with the data binding library. So with binding adapters we can basically create a custom binding attribute for our views inside XML layout file. So with data binding library we can convert any XML layout file to data binding layout, and when we do that, the root element on that layout file will become a layout element, and that new layout element will contain all other views inside. Plus with data binding layout we can now create different variables, and those variables can be easily used to directly set the data on our views. So when we convert our layout to a data binding layout, a new class will be generated behind the scenes. So for example, if our layout file was named fragment main XML, then that new generated class will be named the fragment main binding. So a class with a binding suffix, and that new class can be used to bind the actual data from our UI with the actual variable. And if you are wondering how can we bind that data binding variable with the actual data, well, easily we can do that from our activities or fragments. So for example, let's say we have created one variable inside our data binding layout with the type of a view model class. Now from our fragment we can just create an instance of that view model and just bind it with the same variable which we just created. There is one catch however, so if you want to use live data objects with binding adapters, then you need to also specify a lifecycle owner. And don't worry, that's totally easy, basically just one line of code. And after that we would just create a simple function which would represent a binding adapter, and that binding adapter function would have two annotations, binding adapter and JVM static. So those two annotations are important, and our binding adapter would take some data from that view model as a parameter, and then from our data binding layout we will just add that custom binding adapter attribute to our view and pass the data to it from our view model variable. So don't worry if this looks kinda confusing, everything will make more sense when we actually get started using it in practice. And this was just a short introduction to binding adapters. Hello there and welcome back. So in the previous video we have created the main view model, and with this video we're going to create a recycler view adapter for our fragment recipes. So as you can see here we have a shimmer recycler view, and we want to display a data from our API here. So first we need to add a new package here, and let's name this package adapters. Okay, so inside this package we're going to create a new Kotlin class named recipes adapter. Okay, press enter, and here we're going to extend the recycler view adapter. So recycler view dot adapter, and here we need to pass a view holder. So I'm going to create a new view holder class, so recipes adapter, dot my view holder. Okay, and now we want to create that view holder here. So let's create class my view holder, and we want to create that class inside our recipes adapter. Okay, so here we have a warning from Android Studio. So let's implement members. So we have three methods: on create view holder, on bind view holder, and get item count. So we're going to implement all of those three. Okay, and here we have a warning, and that means that this class my view holder needs to extend recycler view view holder. So type recycler view dot view holder. Okay. Okay, so now before we continue, we need to open our recipes row layout, and here we need to convert this layout to accept the data binding. So you're going to click on this root layout and press Alt plus Enter, and here a new option will appear that says convert to data binding layout. So press that, and you will see that now we have a new root layout element. Okay. And inside we have a data tag as well. So in this data tag we're going to add one variable element, and we're going to name this element result. And here we need to select our model class. So I'm going to select com.example.foodie, then models, and I'm going to choose result model class. Okay, so this is that model class, because we're going to use this exact model class to bind with our recipes row layout. So we're going to bind our API data with this recipes row layout, and we're going to use this variable to set the data to all our views here. Okay, so now that we have created our data binding layout inside this recipes row layout, we need to open up a recipes adapter, and inside the parameters of my view holder we need to add a binding. So let's add a private vol binding, and the type of this variable should be recipes row layout binding. So this is an automatically generated class, and whenever you convert your layout to data binding layout, then this class will be automatically generated. So just select that. As you can see, the name of this class is the recipes row layout binding. So this is the suffix which is automatically added to your name of your layout file. So here we have recipes row layout, and the name of this class is recipes row layout binding. Okay, so now we're going to use this binding to actually bind our API data with this recipes row layout. Okay, so here inside the parameters we need to pass binding.root, and we are passing the root element of our row layout. So press Control Alt plus L, so we can format our code. So now on top of this class we're going to create a new variable named recipe, and this is gonna be an empty list. Okay, and the type should be result. Okay, and choose this one. So this is the model class which we have created by ourselves. So press that, and the type of this variable should be a list of this result model class, and this is our model class. Okay, so those are the information which we're going to receive from our API. Okay, so after that, inside this my view holder class, we're going to create a new function. So function named bind, and here as a parameter we want to use a result. Okay, and inside this function we want to use this binding, then dot, then type result, and this is the actual variable which we have created inside our recipes row layout. So let me just open that. As you can see, this is the variable which we have created, and the type of this variable is this result model class, and we're going to choose that class, and we're going to bind that with our result from the parameters of this bind function. So you will see, and after that we're going to call binding.execute pending bindings. So this function will basically update our layout whenever there is a change inside our data. So here it says that this function evaluates the pending bindings, updating any views that have expressions bound to modified variables, and this must be run on the UI thread, so that's okay. And below that we need to create another function. So I'm going to use a companion object so we can access this function elsewhere. So we're going to create a function named from. Here we want to pass view group, so parent view group, and this will extend or return my view holder. This is the class which we have created already, and here I'm going to create a new variable named layout inflator, and we're going to use a layout inflator dot from. Here we need to pass a parent dot context to pass a context. Down below we're going to create a new variable named binding, and we're going to use a recipes row layout binding to actually inflate the layout. So here we're going to use a layout inflator, which we have created already. The second parameter is a parent, and the third one is false. Okay, and down below we want to return my view holder, so this one, and we need to pass a binding here. Okay, so here with this function we're basically returning this class which we have created, and of course we have passed this binding by inflating the layout, which is actually our recipes row layout. Okay, so that's it for this my view holder class. And down below inside this onCreate view holder we're going to remove everything. And here, as you can see, the return type of this onCreate view holder function is my view holder. So we're going to just return my view holder. So select the proper class here, and we're going to use this from function which we have created, and we want to pass a parent. So we can get the parent from this onCreate view holder, and then with that function we're basically receiving that parent and using that same parent to actually create the layout inflator and binding here as well. So next, inside this get item count, we want to just return recipe. This is empty list which we have created dot size, and that's it. And next, inside this onBind view holder we want to create a new variable named current result equal to a recipe, and here we're going to pass a position. So basically inside this variable we're going to store a current item from our recycler view, because we're using this position parameter to get dynamically the position of our row. And down below we are also going to need to create one function which we're going to use from our recipes fragment to actually set the data of our recipe here. Okay, so we're going to name that function set data. And here as a parameter we need to add new data, and this will have the type of food recipe. That is the model class which we have already created. So basically we're going to call this function from our recipes fragment, and we're going to pass a new data to this function every time. And every time there is a new data from this function, we want to store that new data inside this recipe empty list which we have created inside our recipes adapter. So let's use this recipe equal to new data dot results, and as you can see the type of this new data is food recipes. And as you already know, food recipe contains one field which is a result, and that is the class which we have already created, as you can see. So basically from our food recipes we're getting the results, and we're going to store that result inside this variable or empty list which we have created inside our recipes adapter. So whenever we fetch a new data from our API, we're going to call this setData function from our recipes fragment, and we're going to pass that new data, and then this will update this list automatically. And we need to tell also recycler view to actually update the values when we receive new data. So we're going to call a method named notify data set changed. So whenever we receive new data from our API, we're going to populate this variable with this new data, and then we're going to call this notify data set changed, so we can notify our recycler view adapter to update the views with that same new data which we have received. Okay, so I forgot to do one more thing. So here inside onBind view holder I need to use a holder, and I'm going to call bind function which we have already created, and I need to pass this current result. Okay, so basically this holder is my view holder, and we need to call its bind function to actually bind our variable from our recipes row layout with this current result from our onBind view holder. So this will make our recycler view update each and every time we receive new data from API. So that will be all for this video, and in the next video we're going to continue working on displaying data in recycler view. Hello there and welcome back. So in the previous video we have successfully created our recycler view adapter, and as you can see this is our class. So we have created everything we need to actually bind our data, API data with our recipes row layout. out. There is only one more thing which we need to create to actually complete this, but we're going to do that in the next videos. So don't worry if this may be confusing to you. We're going to continue working on displaying the data in our recycler view, and once we complete everything, we're going to recap once again what we did inside our recipes adapter, and basically each and every step I'm going to explain you again everything you need to know. So in this current video we're going to implement a diffutil in our recycler view adapter. So what is this so-called diffutil? Well, before I give you an answer, let's check the code from our recycler view adapter. So here you can see that we have a function named setData, and that function will be called from our recipes fragment every time there is a new data from our API. So with that function we are passing data to our recycler view adapter so it can show us a list of new data. Now setData function has one parameter, food recipes data, and inside that function we are actually updating our current list, which we already have in our recycler view adapter. And after that we are calling one function named notify data set changed. Now this function is notifying our recycler view adapter about the new data, and it's telling it to update the views. So here it lays our problem. This function is pretty much an overkill for the application performance. And why is that? Well, it's because it's updating the whole list all over again without even checking if our new list of food recipes actually contains some recipes from our old list as well. So this is where diffutil comes in. Diffutil will check and compare old list of food recipes, in this case, with the new list of food recipes, and it will update only those recipes or views which are new. And this is a huge bonus for application performance. Okay, so back in Android Studio. So inside this util package, I'm going to create a new class. So right click, then new Kotlin class, and we're going to name this class recipes diffutil. Okay, so press enter. So this class will take two parameters. So private vol old list, and the type of this variable will be a list of result. This is the result model class which we have already created. So just select this one. And the second parameter will be another list, but this time a new list, a list of result as well. Okay, so this class should extend the diffutil.callback. And now we have a warning from Android Studio telling us that we need to change first the constructor invocation, and we also need to implement some functions. So I'm going to select all of those four, click OK. Okay, so here we have 4 different functions, and let me explain what each one of those functions actually does. So this function named the get old list size, it basically returns the size of the old list. Get new list size, it returns the size of the new list. Then we have our items the same. This function is called by a diffutil to decide whether 2 objects represent the same item in the old and the new list. And finally, are contents the same? This function checks whether 2 items have the same data, and you can change its behavior depending on your UI. So this method will be called by diffutil only if a function named are items the same returns true. Okay, so back in our Android Studio. So first we have get old list size, and here we're going to use the old list from the parameters, and we're going to just return the size. So just let's add the return keyword here. Next, inside the get new list size, we're going to return new list dot size. Okay, so inside this function are items the same, we're going to basically compare and see if those 2 lists are identical. So I'm going to return old list, then I'm going to open up brackets to use this old item position to get this position dynamically. Then I'm going to use 3 equal signs to actually see if those 2 are identical. Then new list, new item position. Okay, and that's all we need to add. And inside this 4th method, the are contents the same, we're going to return old list, old item position, and this time we're going to choose only 2 equal symbols, then new list and new item position. So that's all we need to do to actually create our recipes diffutil class. And now inside our recipes adapter, we're going to change our setData function. So we're going to remove now this notify data set changed, and on the top we're going to create a new variable named recipes diff util, and we're going to call our new class recipes diff util. And here we need to pass two lists. So the first one is old list, and the old list is actually our empty list from above. So this is the old list. And the second parameter here is a new list, and the new list is the one which we have inside our parameters of this set data function. So let's use a new data dot results. So because we are using this result model class and not food recipes, so just use dot result so we can get access to this data. And down below I'm going to create one more variable named diff util result, and I'm going to use diff util to actually calculate the difference between those two lists. And here I'm going to pass this recipes diff util. Okay, and below this I'm going to add one more line. So diff util result dot dispatch updates to, and I'm going to pass this because this is actually referring to this class which is actually a recycler view adapter. So whenever we call this set data function from our recipes fragment in the future, every time this diff util will calculate the difference between our old list and the new list of data which we're going to receive from this function, and it will update only those views which are not the same, okay? And now basically we have increased the performance of our application. But of course there is one more thing. So let me just click Ctrl plus Q on this diff util. So here it says that the diff util is a utility class that calculates the difference between two lists and outputs a list of update operations that converts the first list into the second one. And one more thing, so our diff util is actually running on a main thread, and there is option for us to use this async list defer to use this utility in a background thread, but we're not going to do that right now. We're going to still continue to use diff util, and maybe at the end of this course we're going to replace this diff util with a new async list defer. But for now it should stay this way. I don't want to complicate things more than this at the moment, and basically that will be all for this video. So we have successfully created our recipes diff util, and also we have now removed the notify data set changed function, and we're using our diff util. So that will be all for this video, and in the next video I'm going to show you how to create a binding adapter for our data binding, so we can actually get the data from our API and make some modifications. So for example, when we receive an integer value for our number of likes, we will need to basically convert that integer to string in order to display that in our text view. And for example, when we get the URL of our recipe image, then we need to use our coil image loading library to actually load that image in our image view. And we're going to do all of that inside the binding adapter. And in the next video, we're going to create one, and I'm going to show you how to do all of those things. So at the end, we're going to basically have everything we need to bind our data from API to this recipes row layout, and we should be able to download and display those recipes in our recycler view. Hello there, and welcome back. So in the previous video, we have created our recipes diff util, and we have replaced our notify data set changed function with diff util. So basically in our recipes adapter, or in our recycler view adapter, we have binded our data with our recipes row layout. So as you can see, inside this recipes row layout we have one variable result of a type of result, and that's our model class. So we have binded that variable in our recycler view adapter. And as you can see here, we are using this binding, and we are calling this result variable from our layout, and we are binding that with this result from the parameters of this bind function. And as you can see, this bind function is called inside this on bind view holder, and basically we are passing our current recipe, and we are binding each and every recipe from our API. So I'm going to rename few variables here so they can make more sense. So I'm going to rename this recipe to recipes, because this is a list of multiple recipes. So I'm going to hit Shift plus F6, and now you just type the new name, so recipes, click enter. And down below I'm going to rename this current result variable to current recipe, so Shift plus F6. Okay, and let's rename this to current recipe, click enter, and now it will make more sense. So inside our onBind view holder, we're basically creating a variable which will hold each and every row in our recycler view, and then we are binding that data or that recipe to this recipe row layout through this bind function. So now, for example, when we open up this recipes row layout, we can use this variable to insert the data into a title, into a description, and those other information as well. So for example, if we want to use this variable to display the title from this result class to our text view of title, we can just scroll down below until we find our title text. Okay, and here for the text we can just type this symbol at. Then you need to open up these curly brackets, and inside those curly brackets you need to type the name of the variable, and our variable is named recipe, or let me see, a result. Okay, result, and click dot. Then it will show you all the components or the actual fields in that result class. So we're going to type here title, and as you can see, just press enter. So the title is actually a field inside this result class. So we can find that here. So let me see where it is. Okay, here it is, so the title. So basically we are grabbing this title from our API and we are binding that to our recipes row layout. And as you can see, I'm using this result variable to actually populate the title to this text view. And we have already binded this this variable with the actual data. As you can see here, we have used our variable to bind that with this actual data, which we get from this onBind view holder. We can do that trick for the other views as well. So for example, for the description, we can remove all of that, and we can just use our result class as well. So remove that, click or add @ symbol, then curly braces or brackets, and here just type result.summary. So the summary is a field from our API response which will fetch a description of our recipe. Okay, alright, so basically here we are displaying that value from our API, and down below we have three values for number of likes, number of minutes needed to prepare the meal, and here on our third view we have a leaf, and down below we have 100, and instead of that value I'm going to write vegan. So I actually forgot to do that, so I'm going to write here vegan, and basically we're going to paint this icon and this text into a green color if this recipe is actually a vegan, and if it's not vegan then it will have this default color of gray. So for example, let's open up our result class, and here let's find aggregate likes. So as you can see, we can fetch the number of likes from our API, but the value or the type of these likes is actually integer. So we cannot directly set the text of our text view from the integer. We need to convert that integer to string, and that goes the same for our ready in minutes. So this value has a type of integer, and also we need to convert that to string in order to display that in our text view. And for the vegan, as you can see here, the type is a boolean. So we need to write some logic and say if vegan is true, then we want to paint those views in green. If it's not, then do nothing, okay? And in order to do that, we need to create a binding adapter. So I have already talked about binding adapters in a data binding section, and now we're going to start and create one. So first we're going to create a new package here, and that package should be named binding adapters. Binding adapters. Okay, press enter, and inside this package we're going to create a new Kotlin class, and this will be a class which will hold all the bindings for this recipes row layout. So we're going to name this file or this class recipes row binding. Press enter, and inside this class we need to add a companion object, so we can access the functions inside this companion object elsewhere in our project. So here first we're going to create a function which will convert integer value of number of likes to string. So let's create one function, and let's name this function set number of likes. So this function should have two parameters. The first one is the actual view on which we are going to use this function. And as you can see, our view is actually here a text view. So we can write here a text view. Okay, and the second parameter should be the actual value, and the value is actually integer. So when we check this field here, as you can see, it has a type of integer. So we need to add one integer here, so likes of type integer. Okay, so here we need to use this text view and convert this likes to a string. So text view dot text equal to likes, and let's convert that to string. Okay, so now that we have created our function, we need to annotate our function with two annotations. So the first one is binding adapter, and here we need to specify the name of the attribute which we're going to use inside our recipes row layout. So let's say we want to name this attribute something like set number of likes, so the same as the function name, and it doesn't have to be the same as the function name, but still I think that's a good name for now. And the second annotation will be a JVM static. And JVM static specify that an additional static method needs to be generated from this element if it's a function. If this element is a property, additional static getter or setter methods should be generated. So basically with this annotation we are telling our compiler to make our function static, so we can actually access this function elsewhere in our project. So now when I open this recipes row layout and let's search for this text view, okay, here, and I'm going to write here set, and as you can see it will appear immediately. So set number of likes, and here we need to pass the integer, so I'm going to use a result dot aggregate likes, and this is actually an integer. So we need to pass only one parameter here, and that is an integer. And as you can see here, the first parameter is a text view, but since we have applied this attribute on text view, we don't need to specify anything here. So we need to just specify the number of likes, and we're going to get that number and convert that to string and display that inside our text view. So here, as you can see, we have used this custom attribute, and we have passed this integer value of number of likes, and this function will be automatically called and executed. So we can remove this text attribute, we don't need that, but I'm going to leave that for now, so we can actually see our values here for now. And we can do the same thing for the second value here, for our number of minutes. So inside our recipes row binding we can create a new function, so function named set number of minutes, and here as well we're going to add the text view as a first parameter, and the second one will be integer, so minutes, type of integer. Here let's use a text view from the parameters to set the text, and let's use a minutes convert to string. Okay, and of course we need to annotate this function with those two annotations, so binding adapter, and the name of this attribute should be set number of minutes. And down below we need to also add this JVM static. Okay, and now let's go to our recipes row layout and click on this view here, and down below let's use set number of minutes this time, and let's pass result dot ready in minutes. Okay, so that's the field in our result model class, which will fetch the number of minutes from our API. Okay, so as you can see here, we have set that number. So we have binded the title, description, and those two values. And now we need to create one more function for this vegan. So now we need to create a new binding adapter, but for image view and for the text view. So how can we do that? Well, instead of a text view, we're going to write a view. So let's create here a new function, and let's name that function apply vegan color. Okay, so the first parameter will be a view, and we are adding a view because we're going to use this on both text view and image view. And the second parameter will be a boolean value, so vegan of a type boolean. Okay, and here we need to create some logic. So we're going to say if vegan is true, and now we need to add the when block. So when a view, so when a view is a text view, then we need to set the text color, and when the view is an image view, then we need to use another function called a set color filter. So first here we're going to use a view dot set text color, and here I'm going to use a context compat get color, and here I need to pass a context. And the context will be received from our view. So let's use our view dot context, and the second parameter is the actual color. So I'm going to use r dot color dot green. Okay. So if vegan is true, that means that our recipe is actually vegan, and we want to change our image view and text view color to green. So if this view is a text view, then we want to add this set text color, and when this view is image view, then we want to add some different logic. Okay, so here we're going to use this view again dot set color filter, and again we need to use a context compat dot get color. So view dot context, and the second parameter is the actual color. So r dot color dot green, and that's it. So we're going to use this attribute on both image view and the text view. And that's why we need to check if the view is actually text view or image view. And now let's annotate our function with two annotations. So binding adapter. And for here, we're going to name our attribute apply vegan color, the same as our function name. And down below, we need to add the JVM static as well. So let's open up our recipes row layout. And let's click on our image view of this leaf. And here we want to add apply vegan color. And here we need to specify result.vegan, and we want to copy this same attribute and add that in this text view as well. So now our recipes row layout will check every time if the current recipe is vegan, and if it is, then we're going to paint those two views in a green color, and if vegan is false, then basically it will leave that default gray color as it is. So that will be all for this video. I know that this might be a lot of information for you to process, but don't worry, we're going to recap all of that once again when we actually display the data in our recycler view. And if you're still having troubles understanding some part, I suggest you to watch those videos all over again, and when you watch something the second time, you might understand even more than before. And of course, if you are still having troubles, don't forget, you can always send me a message and I can help you out. So that will be all for this video, and in the next video we're going to work with our recipes fragment to actually display that data in our recycler view. Hello there and welcome back. So in the previous video we have created our binding adapters. So we have created three functions here to convert this integer to string for our number of likes and the number of minutes, and also the third one for applying a green color to our text view and image view. So here when we open up this recipes row layout, as you can see we have one variable here, and we have binded that variable with actual data in our recipes adapter, and down below you can see that we have set the text of this text view from this variable. So we have chose this title, and here we chose a summary, but for those views we needed to add a custom binding adapters. So there is one more binding adapter that we need to add, and that binding adapter needs to be created for our image view here, and we need to use that image URL and display that inside our image view here. Okay, so let's open up this recipes row binding. And here I want to create a new function, so function named load image from URL, and this function will have two parameters. The first is the actual view on which we are going to use this function or binding adapter, and that is an image view, and second one is the actual image URL, so image URL of a type string. And as you can see here in our result, we have one field named image, and that image has a type of a string. So here we're going to use a coil image loading library to load this image from URL into our image view. So this is the actual library which we're going to use, and we have already added a proper dependency for this library, and as you can see this is the actual dependency which we need. And now let's load this image URL. So I'm going to type here image view dot load, and here we need to pass image URL. So image URL from the parameters, And here we're going to use a crossfade effect. Okay, so basically when our image is loading, or when it is loaded, it will have a fade-in animation of 600 milliseconds, and you will see that effect when we actually start fetching some API data. So here I'm going to just set a binding adapter, and the name of this binding adapter should be load image from URL as well. And let's add a JVM static annotation. Okay, so that will be all for this recipes row binding. And now we're going to open this recipes fragment. Okay, so here inside our recipes fragment, first I'm going to create two functions. The first one for showing and the second one for hiding a shimmer effect on our recycler view. So let's add a new function here, private fun. Let's name this function show shimmer effect. So here inside we need to get the access of this view object. So I'm going to make this view a global variable. So let me just remove this val from here, and I'm going to name that private late init var view. But of course I need to rename this to something different. So I'm going to say mview. Okay, I'm going to just return that here and here. Okay, so now that we have our view here, a global variable, now from here we can use this mView to get the access of our recycler view. So recycler view dot show shimmer, and now we're going to create another function for hiding this shimmer effect. So hide shimmer effect. Okay, down below mView dot recycler view dot hide shimmer. Okay. So the next thing, we need to set up our recycler view adapter. So before that I want to create here a private vol m adapter, and I'm going to lazily initialize this. So here type recipes adapter. Okay, and down below we're going to create a new function. So private function setup recycler view. Here we're not going to have any parameter. And inside this body we're going to use mView.recyclerView.adapter, and we're going to set the adapter to our recipes adapter. So down below I'm going to call again a recycler view, and I'm going to set layout manager. So I'm going to use a linear layout manager, and here I'm going to pass a context. And of course I'm going to call a show shimmer effect function from this setup recycler view. And this setup recycler view should be called in on create method. So setup recycler view. Okay. So whenever our application starts, our recycler view will set up, and this show shimmer effect will appear. So basically we want to make our shimmer effect active until we get the data from our API. So now we need to create a new function which will actually start and fetch some data from our API. So here let's create a new function, and I'm going to name this function request API data. So this function will have no parameters, and first we need to initialize our main view model so we can actually call this get recipes function. So from here I'm going to initialize this main view model. So private late init var main view model. Okay, and here I'm going to use this main view model to actually initialize it. So view model provider, here I'm going to pass require activity dot get, and here I'm going to pass main view model class. So main view model class dot java. Okay, and now inside this function we can call this main view model, and I'm going to call this get recipes function. So as you already know, here we need to pass a map of queries. So when we open our main view model, we will see that this function requires us to pass the actual queries from for our API. So before we actually pass our queries here, let me open a web browser and let's see how many queries we have here. So first, as you can see here, this is just an example. So we have the first query with a key of number. Next we have a API key, then we have a type, then we have a diet, then we have a add recipes recipe information, and at the end we have a fill ingredients. Okay, so just so you know. And first we're going to start by adding our number query. And for that I'm going to create another function so we can separate everything from here. And this function will be named apply queries. Okay, so this function should return a hash map, and the key and value should be of a type string. Okay, so inside this function I'm going to create a new variable named queries. Okay, so the type of this variable should be a hash map of a type string for key and value equal to hash map. Okay, so down below we need to add our queries one by one. So use queries, and here we need to paste our query key in double quotes. So the first one is number, so this is the key, and the value should be a number of 50. Okay, so this is the number of the actual recipes we want to get from our request, and we can set this number from 1 to 100, and I'm going to choose 50 for now, but we might change that. And of course I'm going to hard code some of those values for now, but later in this course we're going to get those values dynamically, so don't worry. Okay, so next let's pass our second query, and our second query is actual API key. So from here, as you can see, it says API key. This is the key, and this is our API key, but we already have created our API key in this constants class, so we can just call API key here, and we can import that. So Alt plus enter. All right, so next we have a third query, and every query key should be in a double quotes. So next we have type. So here type. Okay, and in this case I'm going to set that to snack, but of course we're going to get the type and the diet dynamically, but for now I'm going to hard code those values. So queries. Okay, next one is diet, and the diet should be let's say vegan for now. Next we have, let's see, let me open this web browser. So we have typed type and diet. So next we have add the recipe information. I'm going to copy that, and I'm going to paste that right here, and the value should be true. Okay, and finally let's see, what do we have at the end? So fill ingredients. Okay, that should be to true as well, so let's set the value to true. All right, and now at the end we're going to return this queries. Okay, so basically we're going to call this function inside this get recipes, and this function will return a hash map of our queries. So as you can see, the number of recipes we want to get is 50. This is the actual API key which we have inside our constants class. Next we have a type of snack, a diet vegan in this case, add recipe information, and fill ingredients to true. So we have applied the queries, and of course we're going to get those queries dynamically later in this course, but for now they will stay hard-coded values. So basically we have called this get recipes function from our main view model, and this function will basically get the data from our API, and it will store the response inside this mutable live data object. So now from our recipes fragment we want to observe this value. So down below let's call main view model dot recipes response dot observe. Here I'm going to pass view lifecycle owner. Okay, and here I'm going to name this response. Okay, and now I'm going to create a when block. So I'm going to say when response, and the first we're going to check when response is a network result, and check this one dot success. So when our response is successful, then we want to first hide our shimmer effect. So that means that we have received our data and we can hide our shimmer effect. And of course we can choose this response.data to get the access of our food recipe. So data.let, and I'm going to call our adapter, our recipes adapter, and its method setData. And here I'm going to just pass our food recipe which we have received from our API. Okay, so here it's telling us that this is actually nullable, so I'm going to add a question mark here on this data. Okay, and down below we're going to check when response is network result.error. So when we receive error, then we also want to hide the shimmer effect, of course, and also we want to display a simple toast message. So toast make text, here require context. So for the message we're going to get that error message from our actual response. So response message to string. Okay. For the length I'm going to choose length short and just call a show. Okay. And finally, when our response is network result.loading, then we want to show shimmer effect. So when network result is loading, we want to show shimmer effect, and only when our network response is successful or we receive some error, only then we want to hide the shimmer effect. And in this first case, if the response is successful, we want to basically get that data and pass into our recycler view adapter. And if we get an error, we want to display that error message in our toast message, okay? So simple as it can be. So now from our onCreateView method, we can basically call our request API data after this setup recycler view function, and we can try running our application and see what happens. Okay, so our application just crashed. So let me just open this log so I can see what actually happened. So here it says that cannot create an instance of our main view model. And our main view model is properly initialized inside our recipes fragment. So when we open our main view model, we will see that we are using this view model inject. So basically we are injecting our repository here, and we forgot to add one thing here. So we need to annotate our recipes fragment with Android entry point annotation, and also we need to annotate our main activity with this same annotation, because main activity holds our recipes fragment. So let's open our main activity right here, and let's add that annotation here as well. Okay, so now let's run the app and let's see what happens. And as you can see, this is a shimmer effect, and after our request was successful and finished, we are basically displaying that data inside our recycler view. So as you can see, everything works fine. We have received this title, this description, number of likes, minutes, and this vegan as well. So as you can see, when I scroll down, every recipe here is vegan, because I have added our diet to vegan. So every recipe here is vegan, and we also see this green color. So there is one problem here, we don't see any image here, okay? And the reason why is because we haven't added this binding adapter to our recipes row layout. So we have created our load image from URL, but we didn't actually specify that attribute in this layout. So let's open our recipes row layout, and let's search for this image view right here. And here we want to write load image from URL, and here we need to pass a result.image, okay? And now we are passing that image URL, and this function is now basically using a coil image loading library to actually display those images inside our recycler view. So let's run our app again and let's see what happens. So you should be able to see this crossfade effect when the images are loading inside our recycler view. And as you can see, now it works perfectly fine. And we can scroll down below to see more recipes, and you can see this crossfade effect as well. So it works just fine. So that will be all for this video. In the next video we're going to continue improving our application. Hello there and welcome back. So in the previous video we have created all the necessary functionality inside our recipes fragment to actually receive data from our API and display that data in a recycler view. So here, as you can see, we have created this request API function. We have also created some of those functions down below for queries, for a setup recycler view, for showing and hiding the shimmer effect as well. And in this video I want to create a new view model class for our recipes fragment, where we're going to basically cut and paste this part of the code inside that view model, and later in this course we're going to also add some more code in that view model instead of adding more codes inside our recipes fragment. So basically we want to delegate some part of the code from this recipes fragment to our recipes view model. So before that I want to create a new package here, and the name of this package should be view models. So press enter, and first we want to refactor our main view model, and let's drag and drop that inside this new package. Click refactor. Okay, so inside this package we're going to create a new Kotlin class, and the name of this class should be recipes view model. Okay, press enter. So this class should extend Android view model. Okay, and of course we need to pass application here. Okay, and here. So we're going to need this application context later in this course. So first what I want to do, I want to basically go to our recipes fragment, and I want to select this function, apply queries. I want to hit Ctrl+X to cut this code, and I want to paste that code inside our new recipes view model. Okay, so from here we're going to remove this private access modifier. Okay, and don't worry if you see a warning here, we're going to replace this line of code later. So from our recipes view model, what I want to do, I want to make a few constants now. So I'm going to open up a util package and open up this constants class. Okay, so down below I'm going to write one comment. So don't worry if this API key is not located here at this moment. I have replaced this API key so I don't accidentally upload the API key on a GitHub. So here I'm going to write API query keys. Okay, so I'm going to write some constants here. So the first constants will be for this value here, number. So I'm going to hit Ctrl+X to cut that. And I'm going to write here query number, and the value should be number. So I'm going to hit Ctrl+D multiple times so I can copy this const val a few more times. Okay, so the next one is API key, so Ctrl+X, and let's paste that here. So I'm going to name this query API key. Okay, the next one is a type, so Ctrl+X to cut that. Here let's name query type. Okay, next we have a diet. Okay, so diet. Next we have add recipe information. So let's cut that here, let's add that right here. Add recipe information. Okay, and let's add one more, so for fill ingredients. Okay, query fill ingredients. Okay, so now from our recipes view model I can just call those constants. So first here query number, hit Alt+Enter to add that. Okay, next we have query API key, so Alt+Enter. Next we have a query type. Okay, next we have a query diet. Next we have a query add recipe information, and finally query fill ingredients. Okay, Alt+Enter. And now we have basically made constants for all of those keys, and they are located inside our constants class. Okay, so of course later in this video we're going to dynamically get queries for type and diet, and you will see. Okay, so I can remove this constants dot because I'm going to import that with Alt+Enter. Okay, so now that we have created our recipes view model, we can initialize it inside our recipes fragment. So here I'm going to remove this line of code later. So let's first initialize a new view model. So private late init recipes view model. Okay, so I'm going to override a new method here on create. So let me see, on create. Okay, this one. So this on create is called before on create view, and I want to cut this line of code from here, and I want to paste that right here. Okay, so I want to initialize my view models inside this on create method, and we can simplify our on create view method instead. So I'm going to now initialize recipes view model. So view model provider require activity dot get here recipes view model class. Okay, and from here I can just call this recipes view model dot, and it will automatically find this apply queries function. So basically we're calling this function now from our recipes view model, okay? And we don't need to fill our recipes fragment class with all those functions. We can just delegate that to our recipes view model. Okay, so let me just paste our API key here, and I can run the app again so we can see that everything is working fine. And as you can see, our application still works fine. So we have successfully created our recipes view model, and we have moved this apply queries function from our recipes fragment now. And in the next video we're going to recap everything what we actually did to display our API data in a recycler view. Hello there and welcome back. So in this video I just want to recap once again what we actually did in the previous videos. So in order to display our API data in a recycler view, we needed to create a recycler view adapter, and here as you can see it's a very basic and a simple one. And also we have binded our recipes adapter data with recipes row layout. So when we open up this layout, you will see that the root element is now a layout, and we have converted our layout to this data binding layout. So inside we have a data tag, and inside this data tag we have one variable named result, and the type of that variable is a result class which we already created. And that result is actually a field in our food recipe model class. So here as you can see, this food recipe has only one field, and that is a list of result, and this is our result class. So those are the values which we actually get from our API. Okay, and here we are using that variable to actually bind the data from our recipes adapter where we have binded our data. So here on our image view we're using this binding adapter which we have created, and we have created all our binding adapters inside this recipes row binding class. And here you can see all the functions or binding adapters which we have created. So the first one is for actually loading our image from URL, and here we're using a coil image loading library. Then we have a set number of likes and a set number of minutes, and here basically we are just converting our integer to string. And then finally we have apply vegan color, where we are checking if our vegan value is true, and when it is true then we are basically painting our text view and image view in a green color. Okay, so here you can see that we have those binding adapters, and for our title and description we are not using any binding adapters. Instead we're just passing our string values from our result. Alright, so of course for our recipes adapter we have created the diffutil class, and in our recipes fragment we have basically initialized our view models and our recycler view adapter. We have set up our recycler view, and inside this onCreateView method we are requesting a new API data. So this is just a temporary solution, and later in this course we're going to change this code. So basically what we are trying to do, we want to basically read the database instead of requesting API data each and every time. So our database should be a single source of truth, and of course later in this course we're going to also create a room database, and whenever our application starts we want to read from our database, where we're going to store the offline cache of our API data. And if our database for example is empty, then we want to request a new API data. So basically we're trying to achieve that our application reads from a database every time and only requests a new API data when we need that. For example, when a database is empty, or when we explicitly request new data. And of course you shouldn't forget to annotate this recipes fragment with Android entry point annotation, and also a main activity. Okay, so this is an important step because we're using a HILT library for dependency injection. And basically that would be all for this short recap. And in the next videos we're going to start creating our room database and implement offline caching as well. Hello there and welcome back. With this video we're going to start implementing a Room database in our project. But first, for those of you who are not familiar with Room database, don't worry, because in this video I'm going to introduce you with this library. So what is this Room library? Well, a Room library is a part of Android architecture components, and it provides an abstraction layer over SQLite to allow fluent database access while harnessing the full power of SQLite. Room is considered as a better approach for data persistence than SQLite database. It makes it easier to work with SQLite database objects in your app, decreasing the amount of boilerplate code and verifying SQL queries at the compile time. So the main components of a Room library are entity, DAO and database. So entity represents a table within the database. Room library creates a table for each class that has an entity annotation, and the fields in the class corresponds to columns in the table. Therefore, the entity classes tend to be small model classes that don't contain any logic. Next, we have DAO, which is short for a data access object, and DAOs are responsible for defining the methods that access the database. So our DAO will basically contain all SQL queries, and there are already some predefined queries which we can access with annotations like insert, update and delete, or we can write our own custom SQL queries using a query annotation. In the initial SQLite we use the cursor objects, but with Room we don't need all the cursor related code, and we can simply define our queries using annotations in the DAO class. And finally, a database. So the database contains the database holder, and it serves as the main access point for the underlying connection to your application's data. The main advantages of using Room library are compile time verification of SQL queries. So each query and the entity annotation is checked at the compile time, and that preserves your application from crash issues at the runtime. And not only it checks the syntax, but also missing tables as well. Next advantage is of course less boilerplate code, and lastly it's easily integrated with other architecture components like live data. So for those of you who have worked with SQLite Open Helper class for implementing SQLite database in the past, then you know how hard it is to build and maintain one SQLite database. So in the upcoming videos we're going to implement a Room library in our project, and you will see how we can easily implement it in a real project. Hello there and welcome back. So in this video I just want to introduce you with the concept of offline caching. So why do we need offline caching, and how can we implement it in our application? Let me first answer to the first question. So most of the time when we are working with APIs, we want to be able to store the latest response from the server locally, or in other words, to cache it in our database. So we can retrieve and display it to our user whenever our device loses connection with the internet. Now there is one important thing which you should remember. So our local database should always be the first source of truth. So our application should always read from the database and only request a new data from the API when it's necessary. So for example, when the user runs our application for the first time, we will fetch some data from the API, and next every time a user visits our application, we will read from our database and not request the new data from API. The reason is because every API call is expensive for the application performance. We will only request a new data when that's necessary, and in the most cases when a user requests a new data explicitly, or when the new data is periodically required. So depends on the actual use case, of course. And now about the second question, so how can we implement it in our application? Well, there are various ways to achieve the same goal. One of them is through a retrofit library. Unfortunately, I'm not going to show you that way. Instead, I'm going to show you the manual way, where we're going to implement it on our own. And of course, you will see that when we actually start working with our database. So about the app, our app will have two data sources, remote and the local, and the remote data source will use a retrofit library to fetch the data from the server, and the local data source will cache that API response and use it as a first source of truth. After we have created the remote and the local data source, we will create a repository in which we are going to inject those two data sources, and that way we will separate the repository logic and our code will be even more maintainable. So that's it for this video, and you will see all of that in action when we actually start implementing offline caching. Hello there and welcome back. In this video I will briefly introduce you with Kotlin Flow. Okay, so probably you have already heard about suspending functions and you know that those functions can return a single value only, but with Flow we can emit multiple values sequentially. So flows are built on top of coroutines and can provide multiple values. A flow is conceptually a stream of data that can be computed asynchronously. So those emitted values must be of the same type. So for example, a flow integer is a flow that can emit only integer values. And there are three main entities involved in streams of data. The first one a producer, the second one optionally intermediaries, and the third one a consumer. So a producer produces the data that is added to the stream, and thanks to coroutines, Flow can also produce data asynchronously. Next, intermediaries can modify each value emitted into the stream or the stream itself. Of course, intermediaries are optional. And third one, a consumer, and basically consumer just consumes the value from the stream. So now I'm going to show you one simple example of a function that returns Flow. So as you can see here, we have a simple function named simple, which returns flow of integers. And here we have this flow builder. And inside this for loop, the code will run 3 times. So as you can see, at first we have this delay function, which basically delays our coroutine. And then the second one is basically emitting the exact value from 1 to 3. So as you can see, this simple function is not a suspend function, but we need to run this collect inside the coroutine because this collect is actually a suspend function. So that's why we need to call our launch coroutine builder, and here in this example I'm using a global scope, but this is just for the example purposes. And here we are basically calling this simple function, and we are using this collect lambda to actually collect the values. And basically the result here will be 3 printed lines from 1 to 3. And basically after this delay of 100 milliseconds, we're going to print this value, and we're going to do that 3 times from 1 to 3. So collect is a suspend function and it needs to be executed within a coroutine. It takes a lambda as a parameter that is called on every new value. So whenever we emit a new value from our simple function, then this collect will collect that new value immediately and it will print the value. And since it's a suspend function, the coroutine that calls collect may suspend until the flow is closed. So a flow collection can stop for the following reasons. The first one, when the coroutine that collects is cancelled, and the second one, when the producer finishes emitting the items. And in this case, the stream of data is closed and the coroutine that called collect resumes execution. Okay, so next, this code inside the flow builder can suspend. So the flow builder is executed within a coroutine, and it benefits from the same asynchronous API, but also there are some restrictions. So flows are sequential, and as the producer is in a coroutine, when calling suspend function, the producer suspends until the suspend function returns. And with the flow builder, the producer cannot emit values from a different coroutine context. Therefore, we cannot call emit in a different coroutine context by creating a new coroutine or by using a with context block of code, for example. Also with flows, you can use a catch block to catch exceptions if they appear unexpectedly. And when an exception occurs, then the collect lambda is not called as a new item has not been received. So you can call a catch block before collect block and specify a way to handle exceptions. Okay, so that was a short introduction with Kotlin flows. And in our project we will use Kotlin flows to actually send some data from our DAO interface to the repository, and from repository to the view model. And of course you will see all of that when we actually start working with Kotlin flows. Hello there and welcome back. So with this video we're going to start building our room database. So basically we're going to use a database to store our API response inside it. And as I already mentioned in the previous video, the main point of this database is for our application to actually fetch the data from a database each and every time, and only request a new API data when our database table is empty, or when we explicitly request a new data. So first we need to create an entity class. So I'm going to create a new class here. Okay, and we're going to name this class recipes entity. Okay, press enter. So the first thing, we need to annotate our class with entity annotation, and we need to specify a name of this entity, or in this case a database table. So before that I'm going to open up this constants class, and here I'm going to write some constants. So I'm going to write first a comment here, so room database, and I'm going to create first a database name. Okay, so the name of our database should be recipes database, and the second one should be named recipes table, and the name of this table should be recipes table. Okay, so from our entity now we're going to add entity annotation, and inside we need to specify our table name. So table name equal to recipes table, and let's just import this constant, Alt plus enter. Okay, so our recipes entity will have two fields. The first one an integer value for the ID, and the second one food recipe. So for our ID, I'm going to place that ID inside this class body. So var ID of a type integer. Okay, and we're going to set its default value to 0, and we need to annotate this with primary key, so auto generate to false. Okay, let me just add the parameters here. Okay, and as a parameter I'm going to add the food recipe. So basically our recipes entity or our table will contain only one row of a food recipe. Okay, so I have set this ID to auto generate to false, and that means whenever we fetch a new data from our API, we're going to replace all the data from our database table with the new data. So we are not going to have a multiple food recipe. We're going to have only one, and we're going to replace that one whenever we fetch a new data. Okay, so that means that whenever our application reads our database, it will fetch the newest data which we have in our database. Okay, so that will be all for our entity class, and in the next video we're going to create a data access object. Hello there, and welcome back. So in the previous video we have created our first entity class, and as you can see our entity class has two fields. The first is this ID, and we have set auto generate to false, and default value of this ID will be 0. So we're going to have only one row inside our recipes entity, and that row will be populated with this food recipe. So next we need to create a DAO interface. So let's create a new Kotlin interface, and we're going to name this interface recipes DAO or data access object. So press enter, and the first thing we need to annotate our DAO with the DAO annotation. Okay, so this one. And next inside this interface we need to define our queries which we're going to use for our database. So I'm going to add the two queries, so one for inserting our data to recipes entity, and a second one for reading the data from our recipes entity class. So first let's create a new function named insert recipes, and as a parameter we need to add the recipes entity. So recipes entity. Okay. Okay, so next we need to add the suspend keyword in front of this function, because later we're going to use Kotlin coroutines to run this query, and we need to annotate our function with insert annotation. So this one, and here I'm going to specify on conflict strategy, and I'm going to say on conflict strategy dot replace. So that means that whenever we fetch a new data from our API, we want to replace the old one. Okay, so as you can see inside our recipes entity, we're going to have one field here, food recipe, and if you recall, that food recipe contains a list of result, so basically a list of our recipes, and whenever we need to request a new data from our API, we're going to store those recipes inside our recipes entity, and if there are recipes in our recipes entity, then we're going to replace those old recipes with the new ones. And that's why we're adding this on conflict strategy dot replace. So our database table will basically have a newest recipes in a database every time we request a new data from API. Okay, and the second query will be for reading our recipes from a database table. So I'm going to create a new function here named read recipes, and the return type of this function will be a flow. And inside the flow we're going to wrap a list list of recipes entity. Okay, let's add this flow, so Alt plus enter, and be sure to add this Kotlin X coroutines flow, so be sure to add the right one. Okay, this one. So basically, instead of using a live data, we're going to use a flow. So we're going to use a flow in this recipes DAO and inside our repository. But when we reach view model, then we're going to convert this flow to a live data, and you will see. So basically, this flow is kind of similar to a live data, and the data inside this flow is basically circulating whenever we receive some new value. And on this function, we need to add new annotation query, so Android x.room, this one, and here inside we need to specify the actual query, so double quotes, and here I'm going to write select, then this star, so select all from recipes table, that's the name of our table, and I'm going to order by ID, and that's the primary key of our recipes entity, in ascending order. So we don't actually need to do in ascending order, since we're going to have only one row here in our table, but still I just wanted to add this option as well. And that will be all for now. So we only need those two queries for now, but in the future of this course we're going to add more of those queries. And that will be all for this video. In the next video we're going to create a type converter, so we can actually store our recipe or food recipe inside our database, because we cannot store our complex objects directly in our database. Instead, we need to convert them to some primary types like string, integer, long, float, and so on. So we're going to convert our food recipe to JSON, or actually a string, and we're going to store that string in our database. And when we read from our database, we're going to convert back from string or JSON to this food recipe object. And for that, we're going to use a JSON library, so you will see. Hello there and welcome back. So in the previous videos we have created our entity class and our data access object. So as I already mentioned, we cannot store complex objects in our database directly. Instead, we need to convert them into acceptable types, so we can actually store them in a database. And for that we're going to need to create a type converter. So basically, with a type converter we're going to convert our food recipe object into a JSON or a string when we are writing to our database, and convert back from that string or JSON back to our food recipe object when we are reading from our database. So for that we're going to create a new class. So I'm going to create a new class here. So let's name this class recipes type converter and press enter. So inside this class, for now, I'm going to create two functions. The first function, which will convert food recipe to string, and the second one, which will convert string back to food recipe. Okay, so I'm going to first create a function named food recipe to string, and this function will accept food recipe, and it will return a string. Okay, so in order for us to convert this food recipe object to string, we need to use a JSON library, so we can actually serialize our object to a JSON format, or actually a string. And of course we're going to first initialize here one JSON object, so JSON. Okay, and for now we're going to use JSON, but in the future, as I already mentioned, we're going to replace this JSON library with Kotlin X serialization. But for now we're going to use this one. So here I want to return JSON dot to JSON, okay, and here I need to pass this food recipe. Okay, so basically I'm returning a string. So I'm using this JSON library to actually convert this object to a string. And we need to annotate this function with a type converter annotation. Okay, and down below let's create the second function. And this time let's name this string to food recipe. And it will take one parameter, and this time string, so data of a type string. And it will return a food recipe. And here we need to return JSON dot from JSON this time, and here we need to pass our string value. But there is one more parameter which we need to pass here, and we need to pass a type token. So I'm not going to explain you in details how this type token actually works. I'm going to just create one line of code so we can actually satisfy this function. And later in this course, I'm going to replace this JSON library. So before that, let's create here a new variable named list type, and I'm going to use object to get a type token, and here I'm going to pass food recipe. Okay, and here dot type, and here let's pass this list type as a second parameter. So basically this is the way how we can retrieve our string and convert our string back to our food recipe. So with this line of code. And now we need to annotate our function with type converter annotation as well. Okay, so now we have created our type converter, and in the next video we're going to create our database. Hello there and welcome back. So in the previous video we have created our type converter class, and in this video we're going to create our database class. So here let's create a new class. Okay, and we're going to name this class recipes database. So first what we need to do, we need to make our class an abstract class, and our class needs to extend the room database, and after that we need to annotate our class with database annotation, so this one. And inside the parameters we need to specify the first entity. So we have only one table or one entity, so let's specify the name of our entity class, so recipes entity. Okay. The next thing, we need to specify the actual version, so version 1, and whenever you change your database schema you need to increase this version number. And finally I'm going to specify export schema to false. So you can set the annotation processor argument to tell a room to export the database schema into a folder. Even though it's not mandatory, it is a good practice to have version history of your schema in your codebase, and you should commit the schema files into your version control system. So of course this is optional, and I have set this export schema to false, and I think that the default value of this export schema is actually true, as it says here, okay, but I have disabled that. And next thing, inside this database class I'm going to add the abstract function, and I'm going to name this function recipes DAO, and this function should return recipes DAO interface. So if you're wondering where should we add our database builder, so we're going to create our database builder inside the database module in a dependency injection package here, and we're going to do that in the next video. And there is one more annotation which we need to specify here, and basically we need to add down below a new annotation named type converters, and inside this parameter we need to specify our type converter class. So in this case is a recipes type converter class, and basically that's it for our recipes database. And if you're wondering where should we put our room database builder, well, for that we're going to create a database module inside our dependency injection package. Okay, so now after we have created our recipes database, I just want to reorganize my package structure here. So inside our data package I'm going to create a new package, and this package should be named the database, and I'm going to refactor some of those classes into this new package. So let's move this recipes DAO first, click refactor, then we have a recipes database, so move that here as well, refactor. Okay, next we have a type converter here as well, and our recipes entity, of course. Okay, so this is how our application structure should look like for now. So we have a data package, inside we have a database and a network. And that will be all for this video.